Today we're going to practice probability, what we learned yesterday, but first, solve your 2 do now problems and enter your answers. So for number 1, with any percent problem, we can use a proportion to solve. So my proportion is going to start with my percent of 7 over 100, which is my tax. I don't know how much I'm spending in tax, and on the bottom I need to put my total. So first I need to figure out how much he spent. He spent $2.99 on the Airheads and 3 Gatorades. So I don't just want to add $1.15, I need to add 3 of them since he bought 3 Gatorades. So all of those put together is $6.44. So that is going to go at the bottom of my proportion. Cross multiply to solve. I get 100x equals 45.08. Divide both by 100. And I get x equals 45 cents. So this 45 cents right here is how much he would have to pay in tax, because that was the top part of my proportion. But it's asking how much he spent in all. So that means I need to take his subtotal, what he paid before tax, add the tax to it. So he spent $6.89 total for the bag of Airheads, 3 Gatorades, plus tax. Be sure again, as always, that you are checking and correcting your work to fix any mistakes. Number 2 is a simple probability problem that we did yesterday. We are looking for the probability, P, that we will land on a green. So we want the probability that we'll get a green. I see that I have 8 wedges. So I have 8 different outcomes. 1, 2, 3, 4, 5, 6, 7, 8. And I'm only looking for the green. So I have a 1, 2, I have 3 out of 8 chances that I'll land on a green. So my probability is 3 out of 8. I could change that to a decimal by doing 3 divided by 8, in which case we would get 0.375. And to get that to a percent, if I multiply by 100, I would get 37.5% chance of spinning a green. Today our EOG focus question of the day is number 38 from the mock EOG. And this one was part of the calculator active section. So Jacob is 12 years younger than twice Elizabeth's age. Jacob is 28 years old. How old is Elizabeth? So if we think back, this was a problem from our algebra unit. So we need to pick out keywords in this problem. I'm looking first of all for how old Elizabeth is. In this problem, I don't really have a relationship. It's not like I'm comparing speed, miles to hours. I'm just looking at how old Jacob is and how old Elizabeth is. So I want to look at here and think, what is the thing that is not going to change? What is like my total or end amount? And that's going to be Jacob's age. Jacob is 28 years old. We can't change that. So I'm going to write an equation, and I'm going to set it equal to 28. I'm going to let my x be Elizabeth's age. I don't know that. And remember, a variable represents any unknown, whether it's in a proportion or an equation. So we're going to start from the beginning using keywords and numbers. I know that Jacob is 12 years younger. So right now, I know younger means subtract. And then I see that's twice Elizabeth's age. Twice I know means to multiply by 2. So now I'm going to start to put that in this equation. If somebody is 12 years younger, you're basically subtracting 12. Twice Elizabeth's age is going to be 2 times x. Since I don't know Elizabeth's age, which was x, twice is 2 times. And that's just going to be a positive 2. So this is my equation. Negative 12 plus 2x equals 28. However, I can rewrite it so our x comes first, which is normally like we're used to seeing it. So that would be 2x minus 12, since this was a negative, since it was younger, equals 28. From here, I just solve my two-step equation. Add 12 to both sides. Since it's a minus 12, I'm left with 2x equals 40. Divide both sides by 2, and I get x equals 20. So with these types of problems, pick out your key words and determine if it means positive or negative, which is add or subtract, and if it's multiply or divide. Use the strategy we just did to pick out keywords and write your equation to solve this problem. So here I'm looking for how old the sister is. So I'm going to let x equal the sister's age. Check and correct as I go over this. What isn't changing here is Marlena's age. Marlena is 29. That's my total or my end amount. In the problem, I see that she's 5 years older. So automatically older means I'm going to add, or it's a positive 5. Double her sister's age. Double means to multiply by 2. So it's going to be 2 times x, and that's a positive. So I can flip this around so my x is first, so it'll be 2x plus 5 equals 29. So from here I use inverse operations. I'm going to subtract 5 on both sides. I'm left with 2x equals 24. I'm going to divide by 2. And so the sister's age is 12 years old. Here's our last practice with the EOG focus question of the day. Solve this problem on your own. Alright, so I'm looking for how old Amari is. So that's going to be my variable. What doesn't change is Jeremiah's age. Jeremiah is 21. That's the total. But we know that's his total age, and we know that is 6 years younger. So if he's younger, that means subtraction or a negative. Then triple Amari's age. Triple means to multiply by 3. So I'm going to be multiplying 3 times x because I don't know Amari's age. And that's just a positive triple. So we can leave it as negative 6 plus 3x equals 21, or we can flip it so I have the 3x first minus 6, since it's younger, equals 21. Solve my two-step equation. Inverse operations, I add 6 to both sides. I'm left with 3x equals 21 plus 6 is 27. Divide both sides by 3, and I'm left with x equals 9. So Amari is 9 years old. Hopefully now you feel a little more confident with these age type problems and setting up equations to solve. Yesterday we briefly started compound probability. Remember, compound probability is just an experiment that has multiple events. For instance, instead of just rolling a die once, we would roll 2 dice, or we would roll a die 2 different times. I might flip a coin and then roll a die. It's more than one experiment, more than one event you want to happen. So we're going to go through one together to refresh your memory. So with this one, you roll a single die numbered from 1 to 6 twice. What is the probability you will roll an even number and then a 6? So again, the first thing I need to do is determine my sample space, which will tell me all the different possible outcomes that will happen when I roll a die 2 times. Even though this might take a couple minutes to list out all of the sample space, all the outcomes, it is so important that you do in order to make sure you can get these correct and see what's going on. So the first thing I roll, I could get a 1, and then I could roll another 1. I could roll a 1, and then a 2. I could roll a 1 and then a 3, all the way through. As I make this list, you make this list on your paper as well. But I might not roll a 1 first, I might roll a 2. If I roll a 2, I then could roll a 1. I could roll 2 2s, a 2 and a 3. I'm sure by now you can start to see the pattern. This is going to happen for each number on the die. So let's take a few seconds and get this sample space on our paper. Make sure this all is on your paper. That's how we get full credit for today. Also, once you have this on your paper once, anytime you have another dice problem, you'll already have the sample space listed. So it's not like you need to do it more than once. Pause if you need to, but we're going to keep going. So right now that I have my sample space, let's write out my event. So I'm looking for the probability that I have an even number, and then I roll a 6. So first thing I need to do is determine, now that I have my sample space, how many total possible outcomes. 1, 2, 3, 4, 5, 6 in each column, and there are 6 columns, so I have a total of 36 possible outcomes I could get if I roll a die 2 times. Now I only want one that starts off with an even number and then a 6. So this whole first column is out, along with this one and this one, because it doesn't start with an even number. This row right here, 2 isn't even. So if I roll a 2, I then need to roll a 6. So this is a winning outcome. This is a winning outcome, and this is a winning outcome. It starts with an even, and then my second number is 6. So we have 3 out of 36 chances to win. And I can simplify that by 3, and I get 1/12 is the probability of rolling an even number and then a 6. So these 2 problems were on your paper from yesterday. Some of you got to it and some of you didn't. Take a minute, solve both of these problems if you have not already. If you have, go ahead and enter your answers, and then we'll go over them. Alright, so the first thing we want to do is make our sample space. So for the first spinner, I could spin A. And then this one's tricky. Let's say I spin this one right here. That's an outcome. If I spin an A though, I could also spin and land on this one. Those are 2 different outcomes because they're 2 different wedges. There's also another A1, this one right here. There's 3 different outcomes because those are 3 different wedges or different parts of the spinner. Or you could land on A, and then you could land on this too. But you could also land A and you could land on that too. It's a different set of the side of the spinner, so it's a different outcome. And then we have A3. Again, we're going to take the time to make our sample space. Now I might not spin an A, I might spin a B, but the numbers are going to still be the same. I could spin a B and then either this one, or this one, 3 different outcomes. Check and correct your sample space with what I have down now. And it's going to be the same for my C and D. So once you have all of these written out, we need to write the probability we're looking for. So for number 1, we're looking for the probability that I will spin an A and then I'll spin a 2. How many total outcomes are there? 1, 2, 3, 4, 5, 6. 1, 2, 3. There's 4 columns of 6, so that means I have a total of 24 outcomes. I can have this A2 or this A2 as a winning outcome, so I get 2 over 24 or 1/12. For number 2, I'm looking for, we'll go ahead and enter your answer for number 2. So for number 2, I'm looking for the probability that you will spin a C and then a 1. It's the same 2 spinners, so I still have a total of 24 different outcomes. But this time I want a C and then a 1. So this one, and this one, those are all winning outcomes. So the chance of getting that outcome is 3 out of 24, which simplifies down to 1/8. So there's a better chance of spinning and getting the outcome for number 2 than it is number 1. 1/8 is bigger than 1/12. Solve problem number 3 and enter your answer. Alright, so Laura is rolling a number cube labeled 1 through 6, which is basically just a die. And then we're flipping a coin. So I want to know the probability that she will land on a 4, and then the coin will land on tails. So I'm going to go ahead and put my sample space. I could get a 1 and then a heads, and a 1 and then a tails. 2 and then a heads, 2 and then a tails. So this sample space is much smaller because when you flip a coin, there's not many outcomes. So we have a total here of 12 different outcomes. That's my total. How many times can you get a 4 and then a tails? I only see that once, so our probability is 1/12. Solve number 4 now. Alright, so I want the probability that both coins will land on heads. So I want heads and heads. So my possible outcomes are I could get 2 heads, I could land on a heads and then a tails, I could get tails and then heads, or tails and tails. So I only have 4 possible outcomes this time, and I only have 1 chance to get 2 heads, so the probability is 1/4, which is also the same as 25% chance. So for number 5, you're not actually finding the probability of a certain event. We just want to know how many groups of 2 can the Forest Girls make. So really this is just the beginning part of finding a probability. I just need to create the sample space. That would give me the total amount of outcomes. So Natalie could pair with Sarah, Natalie could pair with Gabriella, and Natalie could compare or partner with Maria. I don't want to do Sarah and then Natalie because they were already a group over here. So those aren't two different groups. They're still the same pairing. However, I don't have Sarah with Gabriella or Sarah with Maria. With Gabriella, I already have a group with her with Sarah and with Natalie. So Gabrielle and Maria are the only ones left. These are 6 total different groups they could make. So now I'm going to show you guys a little shortcut way to solve compound probability problems. This is probably going to seem really easy to you, but there is a reason I had you make those lists before. There are going to be times and there are going to be problems where you cannot use this shortcut and where you must create the lists in order to solve. So with this problem, Jakayla is rolling 2 dice. I want to know the probability that she will roll a 2 and then a number greater than 2. So before, we would know we would need to list out all the possible outcomes when you roll 2 dice. You actually already have that on your paper from the problem we did before. So for this one on your paper, we're going to go ahead and write the event we want. We want a probability of rolling a 2 and then a number greater than 2. So when we have 2 probabilities, a compound probability, where the events are not dependent on each other. So what I mean is this: if you roll a 2 on the first roll, and you want a number greater than 2 on the second roll, those are 2 totally different events. I'm going to break these up and I'm going to find the probability for each of them separate. When I roll a die, the probability that I get a 2 is 1 out of 6. The probability that I would get a number greater than 2, we still have 6 total outcomes. These are my number on a die. So greater than 2 would be these numbers. It doesn't say equal, it just says greater. So I have 4 out of 6 chances to get greater than 2. I'm going to multiply these. Straight across, I get 4 out of 36. Simplified is 1/9. So now let's check and make sure that this shortcut actually worked. So if I have my list over to the right and I want a number that starts with a 2, that means I can only look in this column right here. And then we need a number after that that's greater than 2. So this outcome works. It starts with a 2. The second number is greater than 2. This outcome, and this outcome. They all start with 2, which is the first thing we wanted. And the second number, 3, 4, 5, and 6, is all greater than 2. So this was 4 outcomes. And there are 36 here, which is exactly what we got when we used the shortcut. So again, this shortcut is used in a compound probability event when you have 2 different things and they don't depend on each other. And tomorrow we're going to work with more of that and when you cannot use this shortcut. So now you're going to practice a little bit on just now using this shortcut for these problems. And you're probably thinking, oh my gosh, this is so much easier with this shortcut now. This is our last practice for today. So solve these 3 problems and try using the shortcut way in order to solve. If you still want to list out all of your sample space outcomes, then that is completely fine. All right, so we still always want to write the probability, your event. So I want to find the probability that I will land on 1 and then an odd number. So if I separate these probabilities, when I roll a die, the probability of me getting a 1 is 1 out of 6. There's only one 1 on a die, and there are 6 possible numbers. When I roll a die, there are still 6 possible numbers, but there are only 3 odd numbers, 1, 3, and 5. I'm going to multiply those together, and we get 3 out of 36 chances, which simplifies to 1/12. We break up our compound probability essentially into 2 simple probabilities. Next one, Marcel is looking for, when he flips a coin, to land on tails, and then a number less than 3. So when you flip a coin, the chance of getting a tails is 1 out of 2. 2 is heads or tails, and there's 1 tails. I'm going to multiply that by the outcome that when I roll the die, it's going to be less than 3. So when I roll a die, there are 6 possible outcomes, and the numbers that are less than 3 are 1 and 2. So again, these are the outcomes when I roll a die. The numbers less than 3 are 1 and 2. So I have 2 out of 6 chances of getting a number less than 3. So when I multiply them, I get 2 out of 12, which is the same as 1/6. I have a 1/6 chance of getting tails and then a number less than 3. Okay, and my last one, Gabby is going to spin the spinner and then flip a coin. So our event, we are looking for the probability that she will spin a green and then the coin will land on heads. So when I look at the spinner, there are 8 possible outcomes. 1, 2, 3, 4, 5, 6, 7, 8. 8 different wedges of that spinner. There are 2 green wedges, so there are 2 out of 8 chances that you can spin a green. When I flip a coin, the chance I'll land on heads is 1 out of 2. I'm going to multiply those together, and I get 2 out of 16, which can be simplified to 1/8. Alright, so hopefully today made you a little more comfortable and confident with our compound probability problems. Complete these 2 exit questions, and then you're done for the day.